So good afternoon and welcome everybody to welcome to lecture 4. So in this lecture we will discuss divide and conquer method. So and recurrences and methods of solving recurrences. So actually this is part of chapter from our textbook. So if you open the textbook, then you will see let us see. So chapter 4 is divide and conquer. Okay, so there are several topics in chapter 4, like first one, the maximum sub array problem. Okay, and then Recurrence algorithm for matrix multiplication, and the substitution method for solving recurrences, and recurrence tree method for solving recurrences, and the master method for solving recurrences. That means you see that so there are several methods, at least 3 methods for solving recurrences. So what is recurrence? A recurrence is a kind of small method, okay, the iterative method, okay, so that like is kind of recursive method. So everybody is familiar with the recursive method, right? So the process of the process is called recursion. So the term okay came from there, and at the end we have proof of master theorem. So if you can learn this, so at least we will focus so briefly in this lecture how to solve recurrences in multiple ways, and at the end you will see the master theorem is a popular way, one of the best way currently to solve recurrences. Okay, so I like you to go to the book chapter, although so it says 65, there are some extra pages, so maybe 65 plus maybe around 90. So chapter 3 and chapter 4. Okay, so here, so divide and conquer method. Okay, so what is divide and conquer? So divide means divide the problem into a number of sub problems that are smaller instance of the same problem. Okay, so as we have seen in our previous lecture that we use merge sort algorithm using divide and conquer method. Okay, so that means division part is to divide the problem, a large problem, okay, or this can be a data set, large data set, okay, that we need to sort or search, okay, and then conquer, that means okay, then the sub problems, conquer the sub problems by solving them recursively. That means okay, so divide the large problem into smaller and smaller and smaller sub problems, and then in conquer process is that next process is solve the each of the sub problems recursively, not in traditionally, recursively. Okay, and if the sub problem size are small enough, okay, but however just solve the sub problems in a straightforward manner. Okay, so then whenever we divide our problem, we will divide and divide again until we find a substantially small amount that is easy to solve. Okay, and then the last part is combine. Combine means okay, combine the solution that we found from the conquer part, this second part, okay, for the sub problem, and merge them, combine them. That means then you will get the solution for the entire problem. Okay, so this is the concept that we will see that this problem can be solved in multiple ways. So I like you to go through the book chapter. Okay, so read the book chapter, please. So as we see that in our previous lecture we discussed the merge sort algorithm is if we solve it recursively, then its running time is theta 1 is constant time. That means if only one element n equal to 1. However, if elements are more than one, we actually consider elements for large numbers, for thousands and several thousands or maybe millions, okay, of data. And then then the second part, we every time we divide the list into two subparts, right? So then each part will have size n by 2 and then two subparts, and then we solve, or we have theta n part for total number of operations needed. Okay, so then finally we saw that how the running time is theta of n log n, that we found that is one side. We draw a rectangle, right? One side n and then depth as or height as log n. Okay, so this chapter refers to this solving or proving this into three ways. So the substitution method, recursive tree method, and so master method. Okay, so this the master method is the way that we'll discuss. So I like you to go through the main part from this book, okay, then you will learn more. Okay, but let us go jump through our, so the book has in detail, okay, the book has in detail, okay, several pages it has, okay, and it is section by section. Okay, so now let us go to our slide. So okay, so again I'm borrowing slide from Dr. Lee. I would like to thank her for sharing her slides with me. Okay, so we want to discuss the recurrence process using a well-known algorithm that we are familiar with, the merge sort algorithm. Also the book has other processes, okay, so but it's easy, I think it will be easy to discuss this using merge sort algorithm. So as we discussed that, as we mentioned, that there are several ways of solving recurrences, right? Iteration method, substitution method, and the master theorem method. Okay, so recurrences. So as I mentioned, that what is recurrence? Recurrence is it is a programming technique. Okay, so it is a programming technique that is recursion, right? You understand recursion, right? So that is a programming technique in which a function or method calls itself. That we know that in data structure and in CS 1322, I think you learn how to write a program to find factorial of a number recursively, right? So the factorial of number, of any number, is positive and the whole number, integer number. How do we find the factorial? We know that factorial of n equal to n times factorial of n minus 1, and then again the next part is n times n minus 1 into factorial n minus 2, and up to we multiply until we reach to 1, and then 1 is our base case, right? So in that case we see that we can find in regular math we calculate the factorial of a number by this way. Okay, so 5 times 4 times. So actually how do we know that we solve this problem using recursively by this way: factorial of n equal to n times factorial of n minus 1. That is a function that is calling itself, that is factorial function is not done yet, so it is calling again, it is being used again. So how long it will be used? It will be used again, the factorial function will be called use until we reach to a base case, right? So in that case, you know that for finding factorial, the number 1 or 0 is called a base case. That means factorial of 0 equal to 1 or factorial of 1 equal to 1. So in that case, you say, if you say n, if n less or equal to 1, that is it will reach whenever it is at 1, then we factorial of 1 equal to 1, right? So then we will return 1. So that means this factorial function will be returning 1. Otherwise, what we do n times factorial of n minus 1. This is the recursive step, right? Recursion happens here. That means this instead of returning this some value, it is calling again the function. It is going to the it is calling the same function again, but it is decrementing the argument value, right? So this is way, in this way, so at some point it will reach, so n will be every time n is decreasing, so at some point n will be 1, right? So whenever n equal to 2, then this value will be here, the argument will be 2 minus 1 equal to 1. So then factorial of 1, so if that is n equal to 1, then it will return 1. Otherwise, even it reaches to 1, then 1 minus 1 equal to 0, so then it says falls into this criteria. 0 is less than 1, so then it will return 1. So you can use here equal sign or less or equal sign, so no problem. So what is the function of the base case here? The function of the base case here, that it stops the recursion. So if we do not write the base case correctly, then the function will be calling itself again and again for a long time. Apparently it is called infinite time, but actually in reality there is no infinite value actually. Okay, so actually whenever computers, all the memories and memory location will be consumed, memory spaces will be consumed, then sometime program will terminate by itself. But that is not a normal termination. Okay, so merge sort. So how do we solve the merge sort algorithm? Using divide and conquer method. So as we discussed, so the in the divide process, we divide the problem into some sub problems. For instance, divide the input data size. If my data size is an array of A, we say that is S, that into sub this joint part. Okay, there is no overlapping subset S1 and S2, so that the union of S1 and S2 become S. Okay, and then conquer process, the sub problems, solve the sub problems using recursive way. Okay, so each of the sub S1 and S2, okay, solve this recursively. Okay, and then in the combine, okay, so combine the sub problem solution, whatever solution we will get in the conquer process, we will combine them, and then finally we will get our final result. That will be the final result for the entire data set S. Okay, so this is a pseudocode for the merge sort algorithm. So A is an array and is left value and right, left index and right index. So if we say if left index equal to right index, that means we are getting only, how it happens, only we have either we have one value or we are at the middle. Okay, so actually you can consider that you have only one value, so then we will return. Otherwise, what we'll do, we will divide the array into two parts, so into two subparts. How do we divide? We find the mid index. Okay, mid index, how do we find that? Taking the floor method, using the floor method, left value plus right value divided by 2, and then we then here merge sort, we sub we divide the original uh, original array, okay, and actually while we divide we call in the merge sort, so in recursive call will be here, right? So then how do we divide? We call the divided or sub arrays. So how do we call? So for instance, if one part we have a my array size and left to mid, and then the next element mid plus 1 to right. So that means if we combine, if we take union of these two sets, then we will get entire set entire A set or an array, right? So we are starting from left element and we're going to all the way to mid element, and then next to the mid element and to the right element. So that means we are getting the entire array, okay. And then after that what we do, we combine the result merge. What do we combine? Left, mid and right, okay. So here maybe there is a question is that, okay, what is the mid plus 1 is gone, right? What is the mid plus 1 element? So actually, so here when we are merging left, starting from left to going to middle and middle to right, that means mid plus 1 element will be here next to mid, okay, within this second, this portion mid plus 1 will be here, and mid minus 1 will be here, the left side of mid, okay. So this part is the process of divide part, and left, this part is the left conquer, this part is right conquer, so together it is conquer, okay, and this is the combine, okay. At this process, since in this process the merge sort method is calling itself, so that in the merge sort it takes three arguments. One is the array, another is left, another is right. So we need to be careful that we can pass only three elements. And this is another method, merge method, okay, not this is merge sort, this is another method. So now if we see that merge sort algorithm, so if we see this merge sort algorithm, how whenever we have an algorithm like this, what will be the steps for each step, how much time it needed, okay. For instance, let us think that it will take tn, time complexity is n, okay, based on the n is the input size, and how much time it needs. If left equal right, that means it is a constant, right? It is one check, right? That means it will take a time bound theta 1 constant time, okay. It does not left and right, it does not it doesn't matter, depend on the size of the array. Else, so in order then here, in order to calculate the mid value, we can calculate the mid value. This is straightforward, so it will take theta 1 at constant time. Theta 1 means constant time, okay. Then in order to do this, to this left recurse, left conquer, so how much time is needed? T of n by 2, since we are dividing the array into two subparts, so this part will take n by 2, t of n by 2, and this part will take t of n by 2, and the merging process will take theta n, okay, because merging is adding two numbers together. So whenever this will be sorted, so previously part will be sorted, okay, previous part will be sorted, so just merging will take constant linear time, okay, so theta n. So Tn will be Tn equal to 1 theta 1, that is constant time, if we have only one value, nothing to merge, right? Okay, otherwise what do we need? Otherwise will be Tn equal to 2 t of n by 2, that we have 2 t of n by 2 right over here, plus theta n, plus theta n. Okay, what is it? N is greater than 1, especially 2 is also greater than 1, but we will consider for a large n. Okay, so here, so why is 2? Because a number of subsets problems we are dividing into 2, so this 2 tn, then size of the subset. Okay, and the work dividing and combining over here, this will take marks. Okay, theta. So as we discussed in our one of our previous lectures, that so as we discussed previously, that how did we analyze the merge sort? So we see that depth, every time the array is dividing into half, right? So the height h will be, so log n, right? Log with base to n. Okay, and then so this is n size, and this is n by 2. Okay, this is n by 2, and this part is n by 2. Okay, and this part is n by 4, this part is n by 4, this part is n by 4, and this part n by 4. Okay, so so the division will be, so for sequence will be for depth I, sequence will be, number of sequence will be 2 to the power I, and size will be n divided by 2 to the power I. Okay, so but total, this total will be n, right? Every time total will be n. So if we consider this as a rectangle, so this size n, okay, and the depth will be log, this is lg, or we say called log base with base 2n, right? So we can say log n. So that means if this is a rectangle, if you form a rectangle, right, what is the area of this rectangle? N log n, right? Height time height. So the total running time for merge sort algorithm will be big O of n log n. N is for length and height is log n. Okay, so so how do we evaluate the recurrences? So in order to evaluate recurrences, there are some expression that we can consider, that as we saw that if n equal to 1, then we need a constant time, right? The tm will be constant. Otherwise, what do we need? If n greater than 1, actually is a large number, not 2, 3, or 4, 5. Okay, although 2, 3, 4, 5 are greater than 1. So the otherwise 2 tn by 2. Why 2? Because we are dividing into 2 parts, right? And then for each part we will need, with size will be reduced to n by 2. So then if for n size is time needed in tn, then for its half size it will take half of this time, so t will divide by n by 2, plus cn is this n part is merging part, and c is this constant. Okay, so we don't know that for merging 2 elements how many milliseconds or nanosecond a computer processor takes. So whatever that is constant, right? So is c times n. Okay, so actually that, as mentioned, the recurrence is an equation that describes a function in terms of its values for a smaller function. okay, in terms of a base smaller function. Where we get the smaller function's value, we remember that for the base case of the recursion process. Okay, so here are some examples of some recurrence functions. Okay, so this is if n equal to 0, then its running time is 0, then n equal to 1, running time is constant, otherwise we have like there is for n there are some multiple what is that called, function for the second part. So this part, what we are doing, we are reducing the length size by 1, right? We are reducing length size by 1. Okay, and if we here is and if for this part, if we are reducing the size by 2, by 2, like make half. Or if we here in this part we have, if we convert a species to our original list or problem, and each of with length b, with size b. Okay, then total, this will be the total. Okay, so these are the several examples in the book. If you go, please go to the book. Okay, so then you will see more detail about this. Okay, so in your assignment 2, you will be I will give you some problems from the book, mainly from the book or slides. So then you have to read the book, and then you have to give the solution. Okay, so from the book, so please read the book for the solution, like for instance like this. Okay, no, I'm sorry. So there, as I discussed, as I mentioned, there are several methods of solving recurrences. One is this called iteration method, that we iterate through an array. That means every time we go one by one element. So every time we reduce the element by size by 1, right? And the substitution method, okay, and the master theorem method. We will discuss these two briefly, the first two briefly. Okay, so solving recurrences in iteration method. So what is the process? In iteration method, expand the recurrences and work with some algebraic expression as summation and evaluate the summation. Okay, actually what do? We go through in iterative process, we go through each of the elements or sub problems one by one. For instance, as I mentioned, that for the first one is iterative problem, right? So Tn equal to T of n minus 1 plus C is a constant time. So how do we solve this in iterative process? Okay, for instance, initially our Tn equal to T of n minus 1 plus C, right? This part. Then how about if we split this into another part, sub part? That means if we for the entire expression, this was the first initial expression, right? These two lines actually the initial expression. Then if we replace n by n minus 1 again, then what we will get? So we will get T n minus 2, and then from here there will be another constant time, right? Extracted. So that will be C. So that C will be added to this C. That means this is equal to T n minus 2 plus 2C. Okay, so here 1C, this part is one part. When we replace n by n minus 1, and similarly when again we replace n by n minus 1, then we will get n minus 3 plus another c. So there c will be actually 2c plus that another c, the 3c, right? So n minus 3 plus 3c. And by this way, whenever we reach to a base case or very like lower level case, so then what will we get? So t of n minus k plus k of c, wherever k is any integer number, okay, equal to t of n minus k plus say ck. C is a constant, okay, and then k is also a number. So this is the iterative process and substitution method. Okay, so the method for solving substitution is using substitution for solving recurrences is that what the substitution method for solving recurrences is comprised with two steps. Number one, guess from the solution. Guess the solution. Okay, guess the form of the solution. Guess whatever your solution will be, and use induction. Okay, induction is a process. We infer something, or through inference we take a decision through inference or some instant proof. Okay, use that induction to find the constant and show the solution works. Okay, so by induction, so if you can see that it is true for one number, one set, then it is true for another set, it is true for another set, it is true for another set. That means ultimately we can, for after some point, you can say, or you can infer that it probably it is good for all sets, right? Or similarly, if we can solve a problem that is we can prove something is true for n, any number of n, and then we starting from there, if we can solve that, we can show that this problem is also solvable or true for n plus 1, the next number. Then we can conclude that it is true for any number. For instance, we don't know what is the value of n, right? N can be any value. So the next value, n plus 1, the next value, if it is true for maybe 1 million, and if it is true for 1,000,001, then it is solved. Okay? So here the substitute method, so a Marshall algorithm. So what do? We know that for Marshall algorithm running type Tn equal to 2 t of n by 2 plus n. Okay, and then we can guess the answer is big O of n log n, LZ. That means LZ means log base 2. Okay, and we need to prove it by induction. So how do we prove it by induction? That if we can prove that Tn is equal to Cn log n. So initially what we thought that our result will be n log n, right? And if we can prove that this is also less or equal to C times n times log n for any constant number, or for a constant number C is greater than C. Okay, so actually this you will understand this if you took your discrete mathematics course, then you should have learned this. Okay, so here the recursion function is here, is Tn equal to 2t. This is the ceiling, this is called ceiling. Okay, sorry, floor, this is called floor, n by 2, and this side is touching the floor. Okay, and this side is not touching the ceiling yet, so this is called floor. Okay, 2n floor of n by 2 plus n. Okay, and this is the if this recursive function. What is this for? For we know that it is for merge sort algorithm, which we divide every time the array into two parts. Okay, and why do we need cell? We need floor actually in case we have odd numbers of elements in an array. We can easily split that, right? We can get the midpoint, or if we have like odd or even number of elements, so this finding the midpoint we will have, for instance, let me show you. So here we use floor method, okay, to get the floor. So for instance, flip is 2 and then 2 plus this is 5. Okay, then 2 index 2 and 5, then 2 plus 5 is 7. 7 divided by 2, okay, is 3.5, but when you take floor method, then it will be 3. So that means the fourth element, right? So we cannot say, since we are using index, so we cannot say the 3.5th element, 3.5 fifth element, okay, 3.5 element, right? So we have index along constant number. Okay, so now tn equal to 2 tn by 2 plus n. Now we can guess that the solution is big O of n log n, and we need to prove it by induction. So how do we prove it by induction? So one thing is that we can find some positive constants n0 and c by using substitute method, and we can then, if we can prove that tn less or equal to cn log n. So why this side is less than? Because we are saying that c is a constant number that is greater than 0, something greater than 0, right? So if it is a positive number, multiply anything by a positive number will make that positive, right? So then our goal will be to find the constant n0 and c by using substitution method. So how do we do that? Let's see. So okay, so the details are actually in the book, so please go through the book if you want to, you are interested into learning how do we do the substitution method, and that is related to discrete mathematics. Now the third one is the last one, is the master theorem. It is more popular, it is the most popular and then well known theory to solve recursion. Okay, it is called master theorem. Okay, it is well known. So in the master theorem, what do we do? So solving recurrences of in the form of tn equal to a t by a t into n by 4 plus log fn, function of n. What is that here? That means we are splitting the problem or an array or a list, or you can say it can be list of problems, okay, list of data, so into a parts, and each part, so each part with length is divided by b. Okay, so necessarily it is not needed that a and b will be equal, but it must be a must be equal or greater or equal to 1, and b must be 1. Okay, and then fn is a function that is called asymptotically positive function. So what is an asymptotically positive function? Please remember this, if you remember this from your discrete mathematics course, that a function is called asymptotic function, that means if it meets with another line in a far distance, for instance infinite distance. Okay, for instance, if we have this is so this is number line, and then this is y-axis and this is x-axis. So if a function is like okay, okay, so that means this function, it means the y-axis with far distance in infinite distance. Okay, this is called asymptotic function. Okay, and asymptotic positive function, that means its value increases. Okay, so in order to prove, or in order to use the master theorem for solving recurrences, we consider three common cases. So let us think that what are the three common cases. First one is you are familiar with now, right? Big O notation, and then second one is theta notation or constant time, and the third one is epsilon, or this lower bound, right? So this upper bound, tight bound, and lower bound. Okay, for the case 1, if fn equal to big O on n log b is base b a minus epsilon, where epsilon is a positive number, then t1 will be, for this one, t1 will be in log log is base b and a. Okay, so epsilon is a some constant number, but very small number, that is tends to 0. And then in the second case, if n equal to theta in log a n, and then fourth case, the third case will be, that's the second case, the third case will be in lower bound. So it's n log b a plus epsilon. Okay, this is lower bound, that means the actual value goes a little bit higher here, and this is upper bound, so value goes a little bit lower. Okay, so here in the third case, then if n, let's say tn will be n a f of n by b, and less or equal to c times fn, where c is less than 1 and for a large n value. So if we consider case 1, so you see that in this case, for our master theorem is this is the theorem, right? So this is the main theorem we have to prove. So for master theorem, we need to find a and b, right? So there exists some a and b indeed that will meet this this solution. Okay, for instance, here if we find a equal to 9 and b equal to 3, so then what we will get here, a equal to 9 and b equal to 3, that means we will get the value over here n log 3 so here n log 3 and then 9, right? So a equal to 9, if we put a equal to 9 and b equal to 3, then we get this part, okay, so this part actually log, this is 3 and this is 9, base is 3, okay, so equal to log 3 actually 3 to the power 2. Okay, so that means here we get 2 log so here this part is log 3 base 3, this part is 1, right? So equal to 2 times 1 equal to 2 times 1, okay, equal to equal to 2. That means we are getting over here n squared, right? So that fn will be here, this one is n squared and this will be n squared, right, plus f of n. So then n squared part is the dominating part, so then we have time complexity equal to theta of n squared. Okay, so there is no function since n squared is bypass, has more power than fn, so we don't need n consider theta n, we can consider that is theta n squared. Okay, now case 2. Case 2, if it is the case here fn equal to this tight bound n log of ba, okay, so now in this case a and b is greater or equal to 1, okay, and function is assumed to be positive function as well as, so we will find a case, for instance a equal to 1 and b equal to 3/2. So these actually is called actually inducted formula. Some people found already, okay, some people did research and found the solution. Okay, we are not finding a specific new solution, but we are just verifying that someone found a equal to 1 and b equal to 3/2 and fn equal to 1, and then they got fn equal to theta of so this one equal to theta of, actually this will be log n, okay, so this part is constant for instance the actually, so actually it will be log n, okay, so theta of log n LG. Then case 3 equal to is the lower bound. If we need to find a and b, right? So here if a equal to 3 and b equal to 4, if we have, and if we consider fn equal to n log n, then for instance this part log 4 or 3 base 4 and 3 is, it will be less than 1, right? So for any number we know that log base and then log 1 with base 1 equal to 1, okay, although log 1 equal to 0, okay, so for instance log e with base e equal to 1, right? So here that means, but if my base is greater than the actual value, so then it will be less than 1. Okay, and then for this part it will be theta of n sorry and we also gauge the function, right? So this part gauge the function, this part is solution in log n, so this part is constant and this part is n log n, so which part is dominant over here? So this, that means it has n and it has n, so and then it has also log n. Okay, so that means it will be n log n. This part is dominant over n. Okay, so that's all, and in week 3 we will discuss heap sort. Okay, and actually okay, and we will have your assignment 2 and quiz 2, that is that will be due in not in this weekend, that will be due in February, not this weekend, not on 2nd, not on January 31st, but it will be due on February 7th. Okay, so I like you please read the book. Okay, whenever you go through the book, you will find some more detail, and as I mentioned again in your assignment 2, I will give you some problems mainly from the book. Okay, and I will maybe changing a little bit, and then you see that it has more detailed discussion, the book has more detailed discussion, and if you read through this, and then you will understand, I think. So for each of the proof there are some problems. I will pick some problems, not too hard problems, but like medium quality problems from here, like from here, and then I will give you as your assignment. And the last part is, please go through the proof of master theorem. Okay, so for this part, please read through the book, and so or you can do Google search, and then you will see that there are some solutions over there. Okay, so I think that's now for today, and especially okay, the master theorem is the more popular one. So let's see how many problems in the book has. I will not give him any hard problem, but like medium quality problem I will give you. Okay, not too much easy, but not too much hard. Okay, thank you so much, and have a good day.